Hi, this is our first video on doing what's called implicit differentiation. We're not going to do any transcendental functions here. Transcendental functions are non-algebraic functions. Those are like your sine, cosine, exponential functions and things like this. So what do you need to know about implicit differentiation? This is a situation when the equation that you have may or may not be a function, but you cannot express the equation in terms of y, or it may get very, very confusing and complicated. So to avoid that, we differentiate this, but when we differentiate that, we're going to remember that y is something in terms of x, and then when we differentiate y, we are going to apply chain rule. So first question is find dy over dx for this equation. All right? So you differentiate x cubed normally. It's going to give you 3x squared. When you differentiate 4y squared, here's what you're going to do. Obviously, we're going to have 4. When you differentiate y squared, that's going to give you 2y. And because it's y, we are also going to get dy over dx. Derivative of a constant is 0, so we're going to get that. So here's what we have now. And this is going to be our equation. We're trying to find dy over dx. So we're going to get 3x squared on the other side. This side is going to give us negative 8y dy over dx. And the other side is going to have negative 3x squared. And then we're going to divide both sides by negative 8y. So dy over dx is going to equal, negatives will cancel. It's going to be 3x squared divided by 8y. Example 2. Find the slope of a line tangent to this curve at this point. So we're going to have to find the derivative. So when we differentiate that, differentiate x squared, we're going to get 2x. When we differentiate y squared, we're going to get 2y, and since it has y, it's going to be dy over dx. And the derivative of a 25 is going to be 0. So what we can do now is solve this. We're going to get 2y dy over dx equals negative 2x. And then we can write dy over dx, after you simplify everything, is going to be negative x over y. So dy over dx at that point, this is how we often write that, positive 4, is going to be negative, x is 3, negative 3, and y is 4. This is going to be 3/4. Alright, let's try something a little bit more complicated. So what makes this problem more complicated is we have a product here. That means we have to use a product rule, and on top of that it contains y. So when you differentiate this expression here, first we differentiate x cubed, which is going to give us 3x squared times y, plus now you keep x cubed and you differentiate y. The derivative of y is going to give you dy over dx minus. Now we have to take the derivative of 4y squared. It's going to be 4. The derivative of y squared is 2y, and you have to have dy over dx because it's y. And the other side, the derivative of 5x is 5. Okay, so you have two terms that are going to contain dy over dx. Anything that does not contain dy over dx is going to go on the other side. That means we are going to move this over here. So we're going to have x cubed dy over dx minus 8y dy over dx equals 5 minus 3x squared y. We're going to factor dy over dx. It's going to leave us with x cubed minus 8y. It's going to equal 5 minus 3x squared y. Okay, so that's what we're getting. And then we're going to divide both sides by the quantity x cubed minus 8y. And then dy over dx is going to equal 5 minus 3x squared y divided by x cubed minus 8y. Okay, I'll leave it there for a moment so you can take a good look at it. Alright, next problem. This expression, so we have two products here, and each one of them is going to be handled with the product rule. So derivative of 2x squared is 4x times y plus 2x squared times the derivative of y, which is dy over dx, plus another product, derivative of 3x is 3 times y cubed plus 3x times the derivative of y cubed. So when you differentiate y cubed, you're going to get 3y squared, and then it's y, so dy over dx. And on the other side, we're going to have 5x squared. Derivative of that is going to be 10x. Let's rewrite that. Let's simplify it a little bit. So it's 4xy plus 2x squared dy over dx plus 3y cubed, right? Plus 9xy squared dy over dx equals 10x. So these two terms do not contain dy over dx. We're going to move them to the other sides, subtract them. So we're going to have 2x squared dy over dx plus 9x squared y dy over dx equals 10x minus 4xy minus 3y squared. Factor out dy over dx. 2x squared plus 9x squared y equals 10x minus 4xy minus 3y squared, and divide. So dy over dx is 10x minus 4xy minus 3y squared all over 2x squared plus 9x squared y. That's the expression. Yes, they sometimes get pretty complicated. Okay, next problem. Okay, here's a challenge here. We have here, which is going to require its own chain rule. Let's start here. So the derivative of x cubed is 3x squared. So here we differentiate the quadratic function first. That means we're going to have 2 times 5x squared y plus 1 times, and now we're following chain rule, so we have to differentiate 5x squared y plus 1. So what are we going to get here? We're going to get 5x squared. The derivative of 5x squared is 10x times y plus, we're using the product rule here, remember? 5x squared times the derivative of y, which is dy over dx. The derivative of 1 is going to be 0. So we are done here as far as that. So what we need to do is get rid of all these complicated stuff. So first of all, let's divide by this quantity because it does not have dy over dx. We're going to have 3x squared over 2 times 5x squared y plus 1 times, equals, this side is going to have 10xy plus 5x squared dy over dx. So there is only one term with dy over dx. This has to go. So we're going to get 3x squared over let's distribute that, 10x squared y plus 1 minus 10xy equals 5x squared dy over dx. Okay, so we do need to combine like terms, bring these two to a common denominator, so that's going to require you to do the following. It's going to be 3x squared minus 10xy multiplied by 10x squared y plus 1, correct, divided by 10x squared y plus 1. It's going to equal 5x squared dy over dx. And what we need to do now is we need to distribute this over here. So it's going to be 3x squared minus 100x cubed y squared minus 10xy. Right? No, it's supposed to be, I did not distribute this. This is 2. My apologies. This is supposed to be 2, and it's supposed to be 20xy divided by 10x squared y plus 1 equals 5x squared times dy over dx. Okay, and we finally have to divide both sides by 5x squared. And when we do that, we're going to get, so here's what I'm going to do. Because every term in the numerator has 1x, we are going to be able to divide by 1x. That's going to cancel that, make this 2, and cross out the square. So finally dy over dx is going to be 3x minus 100x squared y squared minus 20y all over 5x times 10x squared y plus 1. All right? How do we find the second derivative? So to find the second derivative, what you do is you are going to find the first derivative, and after that you're going to differentiate this again, but I have to show you a little trick to that. So we're going to start with this easy example. The first derivative here, to do that, you're going to get 3x squared minus, to differentiate this, you're going to get 8y times dy over dx equals 0. And then we can say that dy over dx, from here dy over dx, is going to equal 3x squared divided by 8y. This is actually the same problem as the first example. But now we need to differentiate this again. So what you do is you find the derivative. So d squared y over dx squared, this is the notation that we have to use. You differentiate this expression, this is going to require you to use the quotient rule. It's going to be 6x times 8y minus 3x squared times, you differentiate 8y, this will be 8 times dy over dx. It's going to be all over 8y squared. And now here's the tricky part. Well, it's not really a tricky part, but that's the part that you need to remember. See this dy over dx here? See this expression? You are going to replace it. So, what are we getting now? We're going to get d squared y over dx squared. It's going to be 48xy minus 24x squared times 3x squared over 8y. All over 8y squared. We can simplify this, well, we can simplify, so it's 24 divided by 8, which is going to leave you with 3, right? So what we're getting now is going to be 48xy minus 9x squared divided by y over 64y squared, correct? So what we need to do now is to eliminate this complex fraction. If you multiply the numerator by y and the denominator by y, you're going to be able to accomplish that. This is going to give you that d squared y over dx squared is going to be 48xy squared minus 9x squared all over 64y cubed. Okay, so this is how you find second derivatives. Right, we have one more example. We have to find the second derivative of this problem, and this is going to get a little tricky. So let's go ahead and try to do that. So dy, well, first thing you need to do here is we need to differentiate this. So it's going to be 2x y squared plus x squared times 2y dy over dx. That's the derivative here using the product rule. Plus, the derivative here is going to be 6y times dy over dx equals 0. So every term that contains dy over dx is going to stay here. I'm going to try to save us some space, so I'm going to move this term on the other side, factor it out. You're getting dy over dx times 2x squared y plus 6y is going to equal to negative 2xy squared. And then when we rewrite dy over dx is going to equal, because you basically, let me do it here so I don't have to write it many times. If I divide both sides by this quantity, 2x squared y plus 6y, I'm going to be able to simplify that, and it's going to be, so let's take a look, everything divides by 1y, right? So this y cancels, and one of these y's is going to cancel. So this dy over dx is going to be negative 2x divided by 2x squared plus 1. Okay, so that's the first derivative. We need to find the second derivative, so we're differentiating this again. So d squared y over dx squared is going to equal quotient rule, so negative 2 times 2x squared plus 2x squared plus, hold on, am I missing a term? No, yes, I'm missing y here. 2x, okay, so I have to use the product rule, my apologies. So negative 2 times y plus negative 2x, so negative 2x times dy over dx. Okay, so this is actually, let me grab another paper because it is going to get a little complicated. I'm going to continue from here. We know that dy over dx is negative 2xy over 2x squared plus 6, right? Plus 6. This is actually 6, okay? Because this was 6, so it's 6 here. Alright, so let's differentiate this. Need some space here. So dy over dx is going to be d squared y over dx squared. It's going to be negative 2 times y. The derivative of 2x is, derivative of negative 2x is negative 2 and times y, plus you take negative 2x times the derivative of y, so dy over dx. Okay, so you multiply that by the derivative of, by the denominator, 2x squared plus 6. Correct? Okay. And then we're using the quotient rule. So this was just the product rule for the numerator here times the denominator. And now you do minus, so it's going to be plus 2xy times the derivative of the denominator. The derivative of the denominator is going to be, what are we getting here? We're getting 4x, right? All over 2x squared plus 6 squared. Now, okay, so this is the setup. No, I'm sorry, it's about a little bit of confusion, but I think we got it all under control. So this is going to be negative 2y minus 2x dy over dx times 2x squared plus 6 plus 8x squared y all over 2x squared plus 6 squared. So this dy over dx here is going to be replaced by this quantity. So it's going to be negative 2y minus 2x times 2xy over 2x squared plus 6 to all times 2x squared plus 6 plus 8x squared y all over 2x squared plus 6 squared. So now we're going to distribute this quantity over here. This is going to give us negative, so we'll multiply negative 2y by 2x squared plus 6, negative 4x squared y minus 12y. And then we multiply this quantity here by this, which is going to cancel the denominator. That works out very nicely. So minus 4x squared y. Okay, plus 8x squared y all over 2x squared plus 6 squared. And I think we have some like terms here that are going to combine very well, and that's what we are going to get. So it looks like we got 4x squared y, negative 4x squared y minus x squared y plus 8x squared y. So it looks like, let me just double check this one more time, x squared, multiply this, you get 12y. So all these terms are going to cancel. That's have x squared y and x squared y and x squared y. It looks like we're just getting 12y, negative 12y over 2x squared plus 6 squared, and that is going to be our answer. I hope this helps.